Okay, so today I am going to try to modify YTIDV in order to enable really quick cycling through of data sets. I've got a whole bunch of 256 cubed data sets that I generated. I haven't had a chance to look at them yet, so they might look really bad, but I guess we'll find out. And what I want to do is I want to modify YTIDV, or at least figure out how to call the API correctly, so that I can cycle through the data sets and see what they look like. Um, Also, as a note, did you know that here in the where I live, at least in the United States, you can just call the Capitol switchboard, talk to your representatives or their staffers, and share with them your thoughts on various different things. I put the number up here in case you are so motivated to do that. I am going to be turning that on and off at various different times during this if I can remember. Um, so oh yeah, I'm also going to listen to some music today. I actually picked out, this is one of my absolute favorite work albums. It's called Everything Everything. It's a live album by Underworld. Um, it's pretty rad, and it always helps me get in the mood for developing. Alright, so I'm going to toss myself up over here. I'm going to leave the phone number up just for a few more minutes. And I'm going to show you what we're dealing with here. So we are dealing with a data set where I have generated a whole bunch of data values along different time steps. And I generated it by taking spherical harmonics and then interpolating them on regular XYZ grids. Now, this might look like garbage, so we're going to have to figure that out. Let me go ahead and take the banner down just for now, but remember that number, which, let's see, nope, that way, gets you right to the Capitol switchboard. Okay, so let's take a look at this. The first thing that I'm going to do is I am going to load this up into YT using the cool little simple HDF5 dataset. You know what? No, I'm not going to do that. The reason for that is that it requires that you've got your fields listed under various different things. So I'm just going to go ahead and load this up into YT vim load gridded.py. So this is a pretty straightforward system. We're going to do with h5py.file gridded modes.h5 rsf. We'll say data is equal to that. So let's take a look again, make sure that that's exactly what we want. Yeah, time step 00000. Okay, we're eventually going to optimize this a bit more so that it looks better in terms of how we are loading the data, what it looks like and all that. So we will take care of that in a few minutes. But for starters, what we will do is we will then yt.load uniform grid. Okay, so loading a uniform grid is our simplest way of doing this. The code for this is pretty straightforward. What we do is we supply a dictionary of data, and we will call this modes, and we'll call that data. We'll give it our dims, which is 256, 256, 256. We'll say our length unit is 1, just for fun. bbox, we'll define this at the top level. This is our extent. If we set this to 1, or from 0 to 1, it works a little bit better for some things that we are going to be doing. So we'll take care of that. We'll say bbox equals bbox, and I am not going to I'm not going to scale it. I am not going to decompose it either. So let's see. Now all we have to do is we go up here, import YTIDV. Oops, got one more. No, that's the right number. Why is it? Oh, yes, of course. Now we will say RC equals YTIDV render context height equals 800, width equals 800, GUI equals true, and I think those might be the defaults, but add scene to it with that data set. Modes. We'll set no ghost equals true to speed it up slightly. And now let's take a look at this. Alright, so let's see what it looks like. Well, that sure is interesting. Now let's take a look. This data set is a maximum intensity. Let's see if we do a projective integration. Oh, neat. Oh, it's logged. Let's not take a log. Let's reset our color bounds. Okay, that's pretty cool. And this is the very first time step. If we do maximum intensity, reset our color bounds. Yeah, you can see where. So that, I believe, is not an artifact from YTIDV. I think that is an artifact of my interpolation. I'm not 100% sure, but I think that's an interpolation. Or not, yeah, that's an interpolation artifact, not a rendering artifact. So, let's see. Okay. Now the next thing we want to do is we want to be able to cycle this. Again, remember, you can always call your representatives if you live in the United States. Get right to the Capitol switchboard and ask for who you want to talk to. Okay, let's close this down. Now the next thing we want to do is I want to make it so that it's straightforward to cycle the data sets. Now, this gets done with scene data. We have block collections. So what I'm going to do is I'm going to first run this. I'm not going to call rc.run. I'll run this interactively. Something about the way that I set up the IPython threading gets a little bit confused, so I'm not sure that I'll be doing that, but we might come back to that. So if we come back here, sg.components, sg.data, no, let's try dir.sg. We've got data objects, yeah, sg.data objects. So there is our block collection data. So that block collection data has a collection of blocks associated with it. Those blocks, I believe, are not the GPU stuff, but we'll find out in a moment. We have instead these block objects. So data source is set here. You know, it occurs to me that maybe what we should be doing is viewing this as a field, in which case we could use our load HDF5 data. So let's try that out. Let's quit this. Oh, right, can't really. Okay. And what we will do is we will use the load HDF5 file. Now this shouldn't load everything into memory all at once, but it's entirely possible that this will just kill all the RAM in my machine if I've been careless. So load all timesteps.py. Okay, now let's see, we want to do this with yt.load hdf5 file. Time step. Let's try time step 100. Would you have walked away when you walked away? Alright, let's see if this did it. Okay, that seems to have. Let's run it. Oh my goodness. Alright. Let's turn log off. Oh my goodness. Alright. So now we just need to figure out what's the right way to get all these textures to switch between them. I guess what I'll do is, well, yeah, let's try it with the IPython. We'll keep an eye on top and all that stuff to make sure. grep-ri ipython docs. Oh yeah, ipython-i GUI equals piglet. And let's see, usage.rst. Now, if I do this, do I have to disable rc.run? I guess we'll find out. Load all time steps. Okay, so, yep, it's running. Now, what did we decide? We decided that it was blocks equals sc.dataObjects, and I don't think it'll tab complete nicely. Yeah. Oh. Oh, yeah. SG for scene graph. Okay. I guess it will. Okay. Let's see. Add data. ds.fieldList. Oh yeah, it only goes up to 254. Does that switch over my display? It does. Oh my gosh. Okay, so let's now write a quick little script to reset my color bounds and render this. So we will keep an eye on the memory here, but we will check. Now, off-screen rendering. Why don't we just go ahead and do this? We'll do off-screen render.py, off-screen render.py. Okay, we'll load the HDF5 file, render context. We'll give this EGL. We'll do a 1024 by 1024. No GUI. Now, I think I want to turn the log off. Let's see, Unicode volume rendering, sg.components.0.cmap log equals false. Now, the other thing I want to do is I want to set that to be maximum integration is probably good. Let's see now. How do we? Oh yeah, and remember, you can call your representatives. This phone number. We can. We do this. This is in components. Blocks. Oh, you know what? Let me just grep-i reset color map. Oh no, it's bounds. And I got to do a -r. Okay, base component. All right, so I just set the color map bounds invalid. Okay, I'm not sure this is going to work just because I'm not sure I've got EGL enabled here, but if we do have EGL enabled, this should work pretty well. We should be able to do this. Yeah, this music really does work on me. Got 255 of these. We will say it goes up to 254. SG dot data objects 0.add data. Here we'll put the F in there. Time step. I:04D, so that we've got that. No ghost equals true. Okay, and now SG.components 0.cmap bounds invalid equals true. Okay, so now that should do the first part. It should redo that, but now we've got to get back to the point where it's actually rendering it and saving it out. Image equals that, yt.write, bitmap, snapshot, I:04D dot png. Just print out I too. Okay. I might end up going to rc.snap. And in fact, for this, I'm just going to, just in case things get a little bit wonky, I'm going to just do it the first 5. We can then tune it off-screen render. Probably something's going to go wrong. It always does, right? Not yet. Oh, there we go. Missing one positional argument file name. Oh yeah, I got to give it the image too. Ba-dum-bum, 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 ba-dum. Okay, and while it's going, I'll just leave this up there in case you need to write it down. Now let's take a look. Python didn't look like it was taking up too much, but I guess that wouldn't show GPU RAM anyway. Oh, dang it, are you serious? I forgot to put the F. Alright, well, while it's going, I'll just mention that this album is really good. Underworld is wonderful. Their work with Sunshine, the movie, was really good. But I guess they've done a bunch with Danny Boyle. Okay. See if this did it. Okay. Oh boy. That's weird. They sure do look different. Huh. Well, you know what? Why don't we just go ahead and let this run for quite a while. We'll see what it does, because that's very strange. I'm starting to wonder if I messed up when I was doing the interpolation. Suspiciously strange. Okay, now let me go back over here. We'll keep an eye on this as it goes. Oh, it's reordering them in here. Yeah, at 3 it gets really weird. I mean, I guess it's possible that this is all because of color map changes, but it doesn't feel right. Anyway, let's also take a look up top. Python's got a lot in memory. Not sure that it's releasing everything, but perhaps it is. I mean, it's probably not if it's cranking the memory usage up quite that much. So let's go ahead and cancel this out. Yeah, it's taking forever. These look almost but not completely identical, and then with 3 it gets odd. Yeah, I'm starting to think that I did something wrong in generating the images, or generating the interpolation. So let's take a look at that. All right, so we've got this interpolate to grid function. And what we do is we've got it at these fixed radii. No, I'm not exactly trying to simulate a black hole. What I'm actually doing is I'm taking simulations of black holes that are merging. And this particular event was GT0577. And what I'm doing is I'm taking the data set as stored inside the MayaWaves database. And then what I'm doing is I'm interpolating the modes of gravitational radiation that come out of it onto a fixed grid, and then I am visualizing that. So it starts with simulations, but then we move on from the simulations into the part where what I'm trying to do is take and make it into a volumetric representation so that we can visualize it in a slightly different way. So I'm using simulations, but I'm not running the simulations myself. The simulations themselves, I believe, were run with a tool called the Einstein Toolkit, I think, which is a pretty rad piece of software that is developed through an international collaboration of folks. It's designed as this extraordinarily extensible system of modules that can be used for simulating lots and lots of different numerical relativity processes. Now, in general, it's based on something called Cactus, which is a simulation framework that gets used for everything from numerical relativity, like black holes, neutron stars, and whatnot, all the way up to things like they used it to do ocean currents around Louisiana, for instance, as a simulation. So it's a pretty versatile piece of software that they use, and it has a wide array of applications. And this particular one that I'm using the data from was based on simulations of merging black holes. Okay, so I'm going to go over in this screen. Oh, interesting. So I'm rerunning it with a slightly different set of data that I interpolated at a different frequency. And so here, what I did in my interpolation was I loaded up with these modes into radii. I put them on the radii inside r theta phi, and then I supplied this to the quadrilinear field interpolator, where we also include W. Yeah, there's some pretty cool stuff. So you can run it on, if you look at the historical stuff, it's surprising what they were able to run it on before. But now, they run these simulations at supercomputer centers and whatnot. So I work at the supercomputer center here in Illinois, and some of these simulations were run there on a big machine, but I think many of them were run elsewhere. there's some really cool stuff that you can do with what in many cases amounts to really souped up versions of, well, not exactly, but that bears a striking similarity to souped up versions of computers that we're comfortable with. They are fundamentally different in some ways, like they've, the need for being able to communicate between different nodes in the machines is extremely high, and so they have really fast interconnect as an example, so that you can get both high bandwidth and low latency connections between different machines for simulating them. So let's take a look at what this looks like now. All right, so this is my new run. And here, yeah, it really looks like something is going wrong with my input interpolations. So let's take a look at those. Yeah, there's some really great stuff you can do with them. As long as we're talking about them here, let me show you. This is the new machine that they just, come on. Well, this is the current machine, if it'll ever come up. Well, if I can get my web browser to open, but it seems like, oh, you know what, it might be under maintenance. Yeah, okay, here we go. So this is the homepage for Delta AI. This is the current supercomputer that, well, it's one of the current supercomputers being run at NCSA. It's part of inside the broader Delta complex. Delta AI, I think, is the most recent addition to it. But they do some rad stuff on this. There used to be a machine here called Blue Waters that did a fair bit of pretty incredible numerical relativity, as well as cosmology simulations and whatnot. That has been decommissioned, but that did some pretty cool stuff. Let's see if we can figure out why this is. Oh, right. Why don't we instead here, what I'm going to do is make slices. So make slices. And what we'll do is I'm going to skip all of this stuff. And we are going to say for I in range, let's say 255, s equals ds dot r. You know what? No, yeah, we'll do this. 0.5 plot f time step I colon 04d. That's save. Let's see if that'll work for me. Whoa. There we go. This should generate a whole bunch, and then I should be able to, yeah, okay. This should be generating some slices for me that I can take a look at. So what I did when I did this was I zeroed out everything that was inside the innermost radius. Maybe that's one of the problems that I'm running into. You can see some of the artifacts here. But I think, you know what, maybe this is correct, except that the artifacts I'm running into, well, no, maybe what's happening is I'm just not setting my coordinate system correctly, or my bounds correctly. So let's see if I can, let's take a look at this again. I think I might be setting my interpolation wrong. So here, I'm zeroing out anything that's inside the innermost radius. Truncate equals true, new vals, r times 0. So here, I'm saying don't interpolate anything inside a radius of 30, but it should go all the way out to 200. Oh, I've got extent equals 150. Let's do 400 here. And now let's do interpolate to grid. So this should go reasonably fast. Come on. Do I not have it printing the... No, it's not printing it. Okay, so it's going to go up to about 32. It has wiped out my existing system, or my existing set of data that I had interpolated, and is now doing an all-new set of data. Hopefully this will go quickly. I wonder if maybe it's just taking extra long because I'm asking it to compress things. Certainly possible. So let's go back here and take a look at my data sets at the results once again. So now you see this goes 0 to 1. I'm actually going to specify the coordinates correctly next time so that they're in these units. Let me see. I think that to do this, I can specify a bounding box. So let's do bounding box equals, and then bbox equals np.array. We'll specify this goes from negative 150 to 150, right? Is that what I set it at? Extent equals 400, so it should go negative 200 to 200. Okay. And so now when I generate the slices, it should look a little bit better. And what I'll also do is I will set a global color map setting so that we've got our min and our max defined globally. I probably should have had it to just 16 frames, but I can do that next time. I guess this is the awkward part of all these streams when there's some processing that goes on. And I've already said everything interesting I know how to say. I would anticipate that, well, maybe what I'll do is I'll fill in values that are set to 0. We've got the ability inside these renderings or inside the renderer to mask things out so they don't contribute to it. So I think perhaps I will apply a mask. I'll have to figure that out, but I'm already using a flag value, setting it to 0, so I can just go ahead and do zeros there. Ultimately, we're going to take these output values from the renderer. Well, this renderer is actually just a check on the values. I'm going to use them as input to a different renderer in all likelihood. Yes, that is exactly what I'm doing. So there are, I want to say there are actually about 400 and some, or no, I'm sorry, there's a ridiculous number of frames in it. There are actually, let's see, how many? 600. Yeah, we have 600 frames in the simulation, but I just want like 32 so that I can do a gut check on the data for now. 0.93 seconds per interpolation. It sure felt like longer than 30 seconds. I think maybe I forgot to divide by 8. Yeah, I did. Okay, so I am snapshotting them. And now what we'll do is make slices. Oops. Right. I'm in the wrong directory. Okay. So now let's see what they look like. And this is just in slices. So the sphere should be a lot smaller now. Is it? It is not. That's strange. Okay, let's take a look. What did I do wrong this time? All right, so I've got my array of radii. This is the input to the interpolation to try to turn it into XYZ. Extent is 400. Yes, so in fact what I'm doing, and I can tell you, what I've got is I've actually got spherical shells of the data. So nested shells sampled at fixed radii. And what I want to do is I want to turn that into XYZ. So I've got my input coordinates, which are r theta phi, and then I need to turn those back into XYZs. So I supply my interpolation base values in r theta phi, and then I supply my requested values in the computed r theta phi at the XYZ that I would like them at. But I'm confused as to why I'm getting these strange setup. Oh. No, let's see. Oh my goodness. Oh, right. Gridded modes. All right, now let's make our slices on this one. And now, actually, if we watch these come in, we should see the sphere, we should see this region get a lot smaller because it's masking out a much smaller portion of it. Oh, there we go. That's what I want to see. Okay, let's go back up. Okay, so now this is unphysical, obviously. That's just weird interpolation artifacts. I don't know why this is sorting by time. These are possibly interpolation artifacts, but I'm not 100% sure. It looks like it's doing it in symlog, so this is a symmetric log. You'll see this is negative 10 to the minus 9, but we don't actually want anything there. So what I'm going to do, yeah, you can see some crazy cool stuff in this. These are positive, interesting. There shouldn't be any data here. It should be truncating it. So let me see. Here, new val is equals r times 0. Yeah, okay. So now what I want to do is I will manually set everything. We will say new vals inverse good r. Where do I set good r? Good r less than min radii, ampersand r less than max radii. So that's where everything is good. So new vals inverse of good r equals np.nan. Okay. So now let's try that, and I'm also going to try to cut this in half. So this should set everything to nans outside that radius. Now, this might not be the right thing to do, but at least we can then provide a filter later on if we need to. If we set them to nans here, and it should only generate 16, so it's only going to go up there. Now, while we're waiting for this, let me just put the phone number back up in case anybody needs to call their representatives. The way that it's working right now is it is going through and it is setting a bunch to nan. I will use that nan, which is not a number, as a flag for where the values are inapplicable. So, let's see, 10, once it gets to 15, it should be done. And then we'll make some slices again. we should be able to make our volume renderings real soon once I get a good color, a consistent color map for them, or at least color bounds. So let's take a look. Let's see if I can sort these so that they are. There we go. That's what we want. Okay, so this is the interesting part. And once it makes all the slices, I should be able to estimate the values that I want the color bounds to be at. So how do I sort this? I sort by file creation date, descending. There we go. No. Sort by file creation date, ascending. I don't know why I didn't do that before. Oh, yeah. All right, so this is what it looks like. What we will do is we will now set a consistent set of values. Why don't we set it to 10 to the minus 3? Okay, so let's set our zlim. Time step. We want this to be, let's say, 1e minus 7, 1e minus 3. Now, I might have had the syntax. I might have the syntax wrong here, but I guess we'll see. Could not find timestep. Yeah, timestep doesn't exist. Let's go to timestep. All right. All right, there we go. Let's see what it looks like here for 0. Yeah. So the thing that is, oh, you know what? I actually want this sorted by name. That'll be much better. The thing that we can pick out from this, although this is kind of gross, that looks wrong. The thing that we can pick out from this is that we're getting some structure, we're getting these various different things happening, and they increase in magnitude. And that's really the key thing. Now, I don't know why it drops so far down after 12. Could it, you know what, actually that's after the two black holes merge, so they might be in their coalescence phase at that point. Or not coalesce, they might have already coalesced. Okay, so now we've got some values there. Let's go back to off-screen render. Now, let's see, how do we set our color map? That would be in block. I guess it should be under scene components. Blocks, there we go. Let's see. Color, nope. Base component, maybe that's where it is. CMap min and CMap max. All right, let's do this. CMap min, and we will allow it to take the log. Oh, no, we won't allow it to take the log. Here, CMap bounds invalid equals true. We won't do that. SG components 0 dot CMap min equals 1e minus 3. I am using OpenGL. For the slices that I showed a few minutes ago, I am not. But for this part, I am. For the volume rendering. So here, let's do 16. So I'm using OpenGL for this, and in fact, this isn't the most sophisticated of a rendering need. just because, you know what, my skin, I think I might be normalizing this, so it might not really produce anything. Because it's just a grid, there's no adaptive mesh refinement or anything like that in it. Yeah, look at that, that's garbage. So instead, let's turn that off and let's try it again. There's no AMR, adaptive mesh refinement, so everything's the same resolution and all that. So it's not the most sophisticated of rendering needs, but it's still useful to do because we can do it so quickly. Let's see. Now that, all right. Something's going wrong there. Why don't I go ahead and just comment this out and we'll let it auto set the, its values. Yes. So I'm not the only person that has worked on this, but this entire software toolchain is actually built on, so the visualization toolchain, let's see if I can type in here, is all built on a piece of software called YT. And what I'm using right now is a combination of general YT and what's called the YT interactive data visualization toolkit. Yeah, this, something looks wrong in this. I'm gonna have to figure this out at some point. Because if you look at this, you can see obvious artifacts here. It's gross. It's also identical, all these, and it should not be. If we look at our slices, 6 and 7 are not identical. So, oh, actually, they're pretty close to identical. Are these identical? No, they have different amounts of... Alright, maybe that's real. Oh my goodness, look at this. 14, it jumps all the way up to 18. So let's take a look at that. Oh, look at that. Everything's red. Yeah, I'm getting the impression that maybe something strange is going on here with my interpolation. Once it pulls out, 11 definitely looks wrong. You know what? Another thing that might be happening is I'm doing some strange stuff with the OpenGL here. It's possible that something is just not really coming through in it. So I think this maybe is not reflecting everything that I want it to. But this has been a rather successful exploration here in terms of being able to get the data in, changing the data that was accessible. Oh, you know what? I bet it's just running out of memory. There's got to be a way to fix that. Let's go back to my block data. Load textures. So instead of adding new data, what I'm going to do, I'm going to iterate over the textures. We've got this data text. I should be able to take my data texture, which is a texture 3D, just reset the data attribute. That should then deallocate the old one because I've got it set up with traitlets. So let's do this. So here, if we look at our data textures, okay, SG dot components 0, data objects 0. This has texture objects associated with it. Each one of these is a texture 3D. Ah, dang it, it's decomposing them. Oh, man. Okay, so we've got our blocks. Yeah, so here, that gives us an ID and a partitioned grid, so I should be able to yeah, I should be able to take this. This just gives me the grid list. That's the indexed viewpoint iteration. That won't do it. I need to get access to the original grid. Wait, hold on. ds.index.grids. Oh, no, that's, I guess it's already decomposing them. So here, I should be able to write a little function, load all time steps. And then what we can do here is we'll add a scene with time step 0. We'll define a new function, update to time step, call it I, and what this will do is for G, which is their grid, this should be in the same order for our purposes. For G and ds.index.grids, sg.data objects 0.textures g.id. Let's see if that actually just runs. Update to time step. Come on. Let's see if this just runs. What? Texture objects? It is texture objects. let's do this. Let's see if we can get it to go. We'll update to our time step. Okay, so it does iterate. What we will do is we will say now our texture object to.data equals g times f time step 04 I: 04d. And now that should change it. So if I update to the next time step, it should swap all the data out. Yeah, okay. So now if I update to time step 10, okay, we got a as type F4. If I can get this, then I'm going to sign off, but we'll see if that happens. Okay. Okay, so that did it. Oh, but of course it doesn't. Yeah, all this right here is because it's not interpolating to the correct grid size. Dang. So I guess what I need to do then what I need to do is come up with a way to have it remove all the existing data. And the way that it would do that, I suppose, is I really need to do, I need to re-implement this part. Because this is where the blocks happen. Now, this is also where, do I set the textures? No. Load textures. This is where everything actually happens. For block ID and sorted blocks, that gives me ndata block my data. Yeah. Okay. Oh, but I have to go. Yes, that is exactly what you are looking at. Unfortunately, I have to take off. I really appreciate you stopping by, though. Nice to have some company. All right. Thanks for coming by. I hope to see you again sometime. See you later, folks.